Hi folks, welcome back to the channel. Well, at work we've got a problem that needs solving. Let's have a look.
So unfortunately for us, we've got an awkwardly shaped piece of steel, 25 kilograms in weight, stuck down a pipe 70 metres long. Added complications is the pipe is near vertical and the piece inside the pipe is about 60 metres underwater. Now I've had the drain camera down and we've found that it's in an orientation where we think we can grab it. So I've designed a grabber, one with wheels which can travel all the way down the pipe. All what's left to do is build it and go and grab the thing. Let's do it. So the first job here is to make a small box section chassis. Remember, we're operating inside a pipe, so the wider the frame, the higher inside the pipe the grabber will sit. Now I've done some calculations using a piece of cardboard here and the actual size of the pipe, and the width I've chosen should fit perfectly. Now into the design I decided to add a small crossbar or cross member which sits just above the main chassis. This will allow us to change the centre of gravity as the grabber heads down the pipe, depending which bar we rig off. I'm just building this part out of 25mm by 25mm box section and dropping a couple of stiffeners in as well just for strength. Now our old friend, the Unistrut channel, is back. Two pieces are going to get bolted to the top of the chassis here, and this will allow us to move the grabber left or right if we need to adjust it. Next we add the wheels, and with some M10 threaded bar as axles, we can then bolt it all together. Moving on to the grabber mechanism itself now. Well, I did consider using pneumatics for the actuator, but quickly realised that subsea, for every 10 metres below surface, we get robbed of approximately 1 bar of grabbing force. This happens because the water at that depth wants to push the ram back into the cylinder. So that means we're going to have to use hydraulics, and with a small cylinder like this, we're capable of creating a pushing force of 1.5 tonnes at 200 bar. This should be plenty strong enough for what we need. So I'm just giving this hydraulic cylinder a little test now, using this hydraulic hand pump I've got here. Now the good thing about this cylinder is that it's got a spring inside. So when the pressure's released, the spring pulls the ram back into the cylinder, which means we only need one hydraulic hose connected to the grabber. Next we're going to build a housing out of some steel flat bar for this cylinder to sit into, and it'll also have holes at the back so we can pin the cylinder in place. Now the cylinder's mounted, we just need a post at the front of the grabber for the top jaw to pivot round. Just building that now and we'll bolt it in place. So the top jaw will pivot around this pin. Unfortunately, I've got no footage of fabricating the top jaw, but here it is being attached. Now in order to grab this thing properly, we need to maximise friction. So in order to do that, I've made a swivel top jaw here, and this will mean that we get full surface contact with the metal piece. Now I'm quite new to hydraulics, and something what surprised me is the force you can achieve with them. Now this design here of the bottom jaw is the best one I've found to stop the bottom jaw from bending under the pressure of the top jaw coming down on top of it. Now that's the grabber assembly all complete, minus a lick of paint of course. And what follow now, just a couple of tests in the garage, just make sure it all functions properly. So with the grabber finished, we now need to find a way of managing about 100 metres of hydraulic hose on location. Now I've got a cable drum that I found in a skip for this. I'm going to strengthen it up with some steel and make a nice little frame for it to sit in and turn on. Just got the hydraulic punch out here, making light work of all the holes what I needed in the steel. Got some mushroom headed bolts here, and this will stop the bolt head from damaging the hydraulic hose on the inside of the drum. Now we're just building the frame for the drum to spin on now. Now halfway through the battery ran out, so we've only got half the footage unfortunately. So a little bit about the hydraulic hand pump. It can achieve a 250 bar, and I've mounted it in a unistrut frame, means the handle can be operated a lot easier. And I've also added a shut-off valve and a pressure gauge as well.
Folks, all that's left is a few finishing touches. We've sent the grabber off to be load tested because the operation's considered to be lifting, a lick of paint, a few final tests and checks on location, pack our bags and go and grab the thing. Let's do it. Nice bit of success at the end there, folks. All down to the team. I want to say thanks to the guys on location. We had 2 guys on the flange level, we had 1 guy on the hose, 1 guy on the winch, we had 2 guys on the camera and 2 guys watching. I want to say thanks to you all. Also, the project management for allowing us to give this a bash. Much appreciated. Well, that's it for this one, guys. As always, subscribe if you haven't already, like if you did, and I'll see you in the next video.